Szanowni Państwo, przystępujemy do sesji pierwszej dotyczącej zagadnień ogólnych i analizy wrakowiska. W sesji tej mamy 5 referatów, czas wygłaszania 20 minut, tylko pan profesor Witakowski ma 30 minut. Prosiłbym bardzo o trzymanie się dyscypliny czasowej z uwagi na to, że gdyby ktoś zakończył wcześniej, to możliwe są również pytania i dyskusja. Chcielibyśmy, aby ta dyskusja mogła mieć miejsce. Jako pierwszego o wygłoszenie referatu pod tytułem Microdetail Comparative Forest Site Analysis Using High Resolution Satellite Imagery proszę pana profesora Chrysa Cieszewskiego. Pan profesor Chrys Cieszewski reprezentuje University of Georgia, Ateny, Georgia w Stanach Zjednoczonych. Jest editorem i szefem 2 czasopism naukowych Open Forest Science i Mathematical and Computation MCFNS, a także członkiem 3 editorial boards 3 różnych czasopism naukowych. Jego specjalnością naukową jest biometrics, która jest taką kombinacją statystyki, następnie modelowania komputerowego i matematyki dla symulowania naturalnych źródeł. Panie profesorze, uprzejmie proszę o wygłoszenie referatu.
Dzień dobry. Może na wstępie wyjaśnię, że mój referat jest po angielsku.
Troszkę głośniej.
Wyjaśnię, że mój referat jest po angielsku i że powód jest taki, że jest to jedyny język, w którym znam wszystkie techniczne terminy i znam dziedzinę i w tym języku studiowałem i pracowałem przez 30 lat. Chętnie, jeżeli będę z kimś rozmawiał o prostych rzeczach, to niezwiązanych z moją dziedziną, to mogę mówić po polsku. Generalnie rzecz biorąc, mam dosyć taką ostrą dysortografię i jak będę robił błędy, to przepraszam. Tych, co nie lubią słuchać błędów polskich, no pocieszę, że będę mówił po angielsku. Tych, co lubią, pocieszę, że po angielsku jeszcze więcej będę robił niż po polsku. Ale znam techniczne terminy, więc w tym języku będę mówił. Dziękuję. So generally the topic or the background of the topic was such that Gregory Szuladziński dzwoni. So the background of it was that Professor Witakowski introduced to me last summer when I was visiting Poland to teach a workshop at at the agriculture school in Warsaw, and showed me different studies on it. I was very impressed with it because I met a great many people who just were completely either unaware or were completely oblivious to what happened there. And I personally felt that that was a great thing, and I was looking forward to visiting Poland and meeting lots of people who would be very concerned. My experience was actually quite the opposite. So when I saw that this thing was happening, I was very impressed, and when I saw what kind of studies were there, I felt that there was something like a bottom-to-top approach as opposed to top-to-bottom approach. And by that what I mean is that, for example, what? I don't know who that. That's not somebody who's working with me. Yeah. So basically, the way I kind of saw how that could have happened logically would be that a person or people, scientists who are responsible for large area managements in nowadays in the modern technology, are doing it from the air, from satellites, from imagery, from low, high resolution, depending on what they do it for. And in case of my work, I do monitoring of 36 million acres, and the only way you can do it cost effectively is using satellite imagery. I'm just going to go get water. So we do it for different reasons, for different applications, and no. Okay, so we do it using different technologies for different purposes. And in this case, that category would be a high-resolution micro-detail monitoring. On the forest scale, micro-detail monitoring is done for various reasons. For example, looking for timber theft. For example, looking for illegal activities such as building, such as drug smuggling, such as breweries and various municipalities and so on. So for that, we also use algorithms that define about what is a tree, what is not a tree, what happens. And one example here is of monitoring plantations where the algorithms are automatically detecting the patterns of the trees and then monitoring them over time and then checking about what happened in terms of whether something disappears or whether they change and so on. Then there are various resources for satellite imagery. We deal with probably about 20 sources. I give here a little short list of those different satellite sensors that are publicly available that we are using, and depending on application that we can that we analyzed for different purposes. Data sources and quotes and orders. I had a bunch of them here. I was hoping that my computer would be faster, more reliable. When I was testing it here on the site, there was some problem with it, but I'll try to show you maybe just some examples. It's a correspondence, PDF files with correspondence with providers and quotes for the prices. If you can read that for different type of programs. I had a bunch of them open here. I thought that instead of making that's from the same provider, instead of making a slides out of it, I'll just show you the documents, the correspondence or the quotes or the various searches, queries that can be conducted to it. This is just out of curiosity because most people who work with the satellite imagery, they know that. Some people don't know certain things, like, for example, where to get the best price. Well, that is something that I'll be glad to share with it. The prices are very similar across different vendors, but some vendors, for example, require 25 square kilometers as a minimum order, and some other will require 100 for a smaller price. That makes it quite a bit different. So, for example, for the imagery that we bought for 5 different days for Smolensk surrounding the accident, we paid something around $1,000. Our first quote was $2,000. If you know what you're doing, where to look for it, you can find a better deal. You can order the satellite. Ordering of the satellites is called tasking. Ordering tasking, it's quite an interesting sort of adventure because you cannot do it on the spot. You have to plan it ahead of time. One of the things that I find very peculiar, that is sort of related to the tasking in the Smolensk accident, is the fact that the last imagery that was available publicly from before the accident was taken in 2007. Then there was nothing for a few years. Then there was an image available for half of the airport, the east side of the airport, so not the side where the crash occurred, but on the opposite side, available for the day before the accident. And then there was a full image available for the entire scene 5 days before the accident. And then there was one available for a day after the accident. And then there was another one for 2 days after, then 4 days after, and then several others after. I understand, of course, that the imagery that is available after the accident, that is some kind of reaction result. Except that if you know how the satellite works and the ordering works, then you know it, in case I like fall here or something, don't get alarmed. I do it all the time. Recently had some issue with my niece, and it's nothing to worry about. So the ordering of the satellites, when the satellite goes around the globe, it's not something that you can just go to a local corner store and buy, but it's something that has to be planned, and it's subject to various contracts and liabilities and responsibilities and different obligations that could potentially cost a lot of money in terms of not delivering something that was promised on time. So typically, it takes 2 to 4 weeks to order a satellite. However, I can imagine that this is not something to get too excited about, because if somebody came and said that instead of paying $15 per kilometer, they would pay 15,000 per kilometer, then they probably will get it faster. Nonetheless, it is kind of peculiar that 2 pictures were available 5 days and 1 day before the accident, and 1 day after the accident. That's a little too fast even for the flying, I mean, on order. So that's in terms of the initial research and finding the sources, finding the quotes, finding the prices, different type of providers. There were 2 or 3 sensors that were used for taking the images or the pictures over the Smolensk area in the span of a few days. Then, then what you've got, it's hold on, oops, went wrong here. Okay. So then I'll go quickly over some uses and some things that we do with the satellites. This is, by the way, the 2007 image of that airport. There is nothing really to get excited about. There are some trees there. There's nothing there to be interested about. Here you've got the frames that we ordered that were dictated by the very peculiarity that something was available or not. So on this frame here, that's what you have, is the availability of the imagery the day before the accident. The accident took place here. The image finishes here. This is about 1 kilometer, maybe 1.5 kilometers from the site. Typically, the way the satellites work is that there are digital sensors that process a signal and that do it under certain angles. Depending where they fly, they get bigger angle or smaller angle, but typically what happens is that on the edges of the image, you get some dropouts. You got different frequency bands, so you've got several processors, and some are visible, some not, some are harder, some are easier to process. And what happens is that usually on the edge, you get kind of like a rough data, so images are usually clipped. So what you're buying is actually not the entirely collected data, but what you're buying is what the vendor feels it's a decent merchandise that they want to sell. And so when we saw it that it was finished here, we got very excited about it and started really, really hard calling up the ladder to find out if we could get the raw data, the before processing, before clipping. It was a great surprise that we couldn't get even a meter farther. So this was quite a kind of disappointment. But nonetheless, even if we got some, there was no way we could get a kilometer farther. We could get probably maybe 10 rows more of the data would be 5 meters, approximately. The other scene is the other frame here that overlaps are the other dates that were all available. The date on the 14th I'm sorry, the image on the 14th, however, was done from 60-degree angle, which is a very strenuous angle, very difficult to interpret. It's like taking a picture of this screen from this angle and trying to figure out what it is. But now imagine that the picture is three-dimensional, so it has some shades and has some different angles that you see and don't see, and so things have different shapes. So there's a lot of work in correcting it so that the images become compatible. So you get general image like that. It looks like a bad picture. You have a picture from a week before. That's an interesting picture I'll be talking about a little bit later. It's a very poor quality. It was something done, seemed like not as a regular flight, because even though the resolution is the same, 0.5 meter per pixel, what happened is that it's an extremely high angle, and everything is kind of like difficult after you auto-rectify the image. Which is what you do when the images are taken. They're not quite aligned. They're not the points, the latitude and longitude points do not overlap with each other, and you have to sort of like find the spots that you know that for sure they are the same, and then you kind of stretch it and recalculate everything so that the image gets sort of like a grid, rubber grid, adjusted so things are on top of each other if you want to look at it for time series analysis, for some kind of changes over time. So one thing that right away kind of called my attention was that snow patterns. Here you've got some snow, you've got like ditches, little kind of here. You've got along the road some kind of snow. You've got at the edges of the forest. You got little patches here. A very common thing when you see it drive by the roads and you see there is a little sort of niche. The wind doesn't get there, doesn't blow it away. So you have it here. You've got here in this part and so on. What's unusual, if you look everywhere here, you've got this little snow somewhere here and there. But what's unusual is this huge pile of snow here. Well, of course, it could be a valley. And if there's a valley, then the snow gets... how much time do they have? Minutes? Oh, fantastic. well, then I guess we speed up to the 30 frames per minute. We'll have, per seconds, we'll have a movie. This is inverted to see it a little better. Here it's a next date. Again, you see the crash already. I hope I can make 40 slides in 2 minutes and show you the later, otherwise I'll come back here. Then I wouldn't want to have any question session, so if this is 15 minutes, 2 minutes to 15 minutes, then please just extend it to 20 minutes, so give me 7 minutes. I'm not going to be... so, I mean, I can do some questions later. So then you've got, depending on what you do with the images, you see better one things than other. And like, for example, here there's a inverted... a picture is an equivalence, digital equivalence of an analog negative. And so you see it's kind of odd here, but you see the roads very well, for example. So if you want, depending on what you're looking for, you're doing different things with it. Okay. Here we've got a April 12th, that's a day later. If you just look at it like this there, you will not notice really all that much difference. Unless you have a keen eye, then you'll see that in this area of the road here, there seems like an access road from this highway over there, goes under the trees, and it goes from there as well, and there is a like a not intersection or a sort of fork of it, and there used to be a big piece there. So either if you have a keen eye, you see it, or if you see presentation of Professor Novacek, you see it, because that thing, I thought I found it. I told somebody, oh, really? And then later I see it all over the internet. Everybody talks about it. They already found it 2 years earlier. Then you have a different manipulation of the filters so that you can see better the same thing, roads, more visible subjects. And then you move to next date, you start seeing again when you look at with the bare eye and you just try to look at in various ways. You notice something, you don't notice something else, but it's clear even on the visual inspection there are a couple of things that are clear and are kind of interesting to notice. One is that the stuff is moving around, which then it's not really a big mystery, because if you look through the internet you'll see all kind of bulldozers and stuff going around and doing it. And then if you look at the same time at the images at different ways, you don't see a single bulldozer on the picture. So what you see here is vehicles parked, and on each one of them all kind of, you can almost see bicycle parked there, but you don't see those bulldozers, backhoes, some other forklifts and so on that you see on the internet. Well, just several weeks later you got a nice what you might call a sound ground or whatever, everything given out, nothing, you cannot see anything anymore. And then it's a question what you saw. So now again, just quick look at what we saw here. Here, here, here. Well, just as a person kind of pretending that I don't know what it is, and I'm a forest manager, I see the land, something happened there. I'm thinking what happened, somebody's building something, somebody's stealing something, somebody's doing something else. Of course, a possibility, or I hear that there was a plane crash. When I say plane crash, so I go to the literature and I read a bunch of engineering studies of patterns of crash, what the crash looks like. It's a 10-volt wheel machine. As a person with engineering background, I go through this and I see those kind of things like you see here on the pictures I put out. Of course, you can see a lot of mathematical equations and a lot of proofs and graphs and so on, but this is kind of thing that probably anybody can relate to. This is what happened to different tubes, not tubes, vehicles, things that happen when they hit something, when they fall something, when they crash something, when they have some kind of frame, and that frame get distracted by something, when they get hit, and when they get different forces from the side twisted around and so on. And you, of course, you can also watch YouTube and you find some plane crashing and you see a big piece of a plane and a small piece of a plane and 100 other small, tiny pieces of the plane. But you don't see million pieces small, every single one spread out at 150 by 50 meter area. So this here is just more of it. Then you look again at this thing, and I guess this is where I kind of found the irony, is that I see physicists and mathematicians or whatever looking at it, and I'm thinking like, well, this is actually me who should have looked at it, and I should have called the physicist and say, what's happening here, because I don't know what it is. If I find a pile of something in the forest, then my first question is it illegal dumping? Is it nuclear? Is it radioactive? Is it maybe toxic? And so I call a chemist, I call a physicist or whatever, and they're going to analyze that, and that's where that would start with for me. So that would be from engineering background that I have, and from satellite imagery. And literature here that it's not all that much of it, but that's quite substantial. I had, I think, twice as much as I looked through. I see that that is a suspicious thing that doesn't look like a plane crash. Even though I'm not a pilot, I'm not, it's just looking this literature, inverting, looking at it in ways that I like it, that I don't like it. Here, next thing I see is that pile of snow. So I mean, at that point, I'm starting being sort of curious about what else can I find in those images. 2007, no images for several years, and then all of a sudden I've got images 5 days before, 1 day before, day after, 2 days after, and so on. So this is pile of snow. Here is the next picture. That pile of snow is gone, so likely it goes melted. If it goes melted, then this stuff is wet, but it's light. That means it's dry. So when you look again, you have a pile of snow here, right? And look at that spot, that melted, that is a dark spot. It's a wet spot. Wherever you have a snow, unless it's sublimated and disappeared, is it time? Oh, thank you, okay. That is, in that case, last thing to leave you with it, if you want to look at weather pattern and temperatures records from that time, then I'll leave it for you for the future. Much.
Mr. Professor, thank you very much for very interesting presentation. O następny referat proszę.